Hi guys, let us understand what are quartiles. Again, we start with a definition. You can write it along with me, guys. The data is arranged in ascending order and is divided into four equal parts. Then there are 3 points of division called as quartiles. Let us understand this with the help of a small number line. Suppose, guys, if you have a scale, let us say from 0 to 100, and when I want to divide this scale into four equal parts, you can see that there are 3 points: first point, second, and third. So these 3 points of division, they are called as quartiles, denoted as Q1, Q2, and Q3. So guys, Q1 over here is called as the first quartile or the lower quartile. Q2 is called as the second quartile. There is one more name which I'll give you in 2 or 3 minutes maybe. Q3 over here is called as the third quartile or the upper quartile. Now guys, when you are dividing the data into four equal parts, then obviously each part should consist of 25% of the total data. So in that case, if you observe below Q2, there is 25 and 25, 50%. Above Q2 also there is 25 and 25, 50% of the data. So it means that Q2 is dividing the data into 50-50. So it means that both the parts to the left and the right of Q2, they are equal to each other. And therefore, the second quartile also represents the value of the median of the given data. So if in a certain question you are given the information about the median, still we can consider it is the second quartile itself. Now, one more important point you can remember: lesser than Q1, there is only 25% of the observations, but greater than Q1, we can see that there is 25, 25, and 25, 75% of the observations. Whereas it is exactly opposite with the Q3. Greater than Q3, there is only 25% of the observations, but if you observe the part lesser than Q3, 25, 25, and 25, 75% of the observations lie to the left of Q3, so they are lesser than Q3. 25% observations lie to the right of Q3, so they are greater than the value of Q3. So that is the basic definition and the basic meaning of quartiles. There are three quartiles, Q1, Q2, and Q3, which divide the data into four equal parts. Each part consists of 25-25% of the total observations. To the left of Q1, there are lesser values than Q1, so there is only 25%. Greater than Q1, there are 75% of the observations. Q2 divides the data into two equal parts. So it can be called as the median. Q3 is the third quartile or the upper quartile, which divides the data into 75-25. That is 75% is lesser than Q3. 25% of the observations are greater than the value of Q3. Now let us understand how to calculate the quartiles for various kinds of data, raw data, discrete or ungrouped data, and the group data with the help of examples for each of them. So give the heading all of you guys, formulas. Number one, for the raw data. Quartile is given by n plus 1 upon the fourth observation. It is similar to the previous example, or in fact I should say the previous formula that we had used for the median, where we had taken as n plus 1 upon the 12th observation, where n was the number of observations. So here also it is the same thing, it is number of observations. But one thing that you need to remember over here now is that you need to multiply this with I, where I is representing the quartile number. Now quartile number means there are three quartiles, so I can be 1 or 2 or 3 depending on what is being asked to us in the question. So the notation is Qi and the formula is I times of n plus 1 upon the fourth observation. So if you want to find the value of Q1, it is 1 into n plus 1 upon the fourth observation. For Q2, it is 2 into n plus 1 upon the fourth observation. And for Q3, I value is 3. So it is thrice of n plus 1 upon the fourth observation. This is the way we will be applying it in the formulas, in fact in the examples when we are solving them. Before directly going to examples, let us also write down for the discrete data, and then we will take examples for these both cases together, and then I will come to the third kind of the data. Formula number 2, which is for the discrete data, or you can also call it as ungrouped data. The similar formula that we have to use over here, the only change that you need to remember is instead of small n, I will write it as capital N. So the formula that I get is again capital N plus 1 upon the fourth observation. If you remember, for median, I had taken it as capital N plus 1 upon the 12th observation, because there is only one median, only one middle value. There are three quartiles, that's why we need to multiply this with I. So I get I into n plus 1 upon the fourth observation, where again over here capital N is the total frequency and I as usual represents the quartile number, where I can be 1, 2 and 3 once again. So we don't need to write that once again over here. Again the similar formula that we had seen for the discrete data also, what you can do is you can replace I by 1, so you will get Q1, replace I by 2, so you will get Q2, and replace I by 3, so you will get Q3. So now let us see the examples for these two cases guys, and then we can go to the third type of the case. Example number 1, let us find the mid quartiles for five, 9, 4, 2, 7, 8, 11, 6, and 7. So there are 7 observations. So let us see what we can do in this. The first thing that I will be doing is to find the ascending order. Ascending order is smallest value that you have over here is 2, then comes 4, then comes 5. After 5 we have 7, 8 and 9. Then we are having over here the last number as 11. So n over here is not 6, in fact 7. There are 7 observations in this case. So therefore q1, 1 into n plus 1 upon the fourth observation. So that is 7 plus 1. 8 upon the fourth observation, which is nothing but the second observation. So guys, what is the second observation over here? It is 4. So you will get over here q1 is equal to 4. Very simple. Then when we talk about q2, it is similar case, 2 into n plus 1 upon the fourth observation. But now over here guys, what you can do is n plus 1 by 4 you have already calculated, it is the value as 2. So I can directly say 2 into 2th observation or second observation, which comes out to be the fourth observation. So remember guys, fourth observation in the ascending order is 7 over here. So you will directly get q2 is equal to 7. Always put the final answers in the boxes so it becomes very easy for your examiners to identify your final answer. q3 is 3 into n plus 1 upon the fourth observation, which is n plus 1 by 4 is 2. So 2 into 3 into 2th observation, which is going to be the sixth observation over here. So in the ascending order, the sixth observation over here is 9. So you get the final value q3 is equal to 9. So guys, next example there in front of you is again to find all the quartiles, and the given data is like this. Once again, the first thing that we will be doing over here is to write the ascending order of the observations. So we will say that the ascending order is obviously from the smallest observation we have to start. So here I can see the smallest value is 20, but it is being repeated for 2 times. So guys, remember, as I had told you in the case of median also, if any value is being repeated twice or thrice, you have to consider it for that much number of times. So after 20, the next number that we have is 24, 25. After 25, the numbers that are available are 32, 35, 35 for 2 times. After 35, we have got over here 37 and 40. After 40, the next number that we have is 41 and 42. So all of them have been taken up. So now when I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So I can understand that there are 11 observations. So once again, when I want to find the value of q1, you can easily say it is 1 into n plus 1 upon the fourth observation, which will give me 12 by fourth observation. and that over here is the third observation in the ascending order that we have just now made. It is 24. So I can easily tell Q1 is equal to 24. Then, in order to get the value of Q2, it is 2 into n plus 1 upon the fourth observation. It's very easy for you guys. N plus 1 by 4 we have calculated to be the third observation. So 2 into the third observation, which is going to be the sixth observation in the ascending order. So it is third, fourth, fifth, and sixth, which is 35. So you will get Q1, in fact, your Q2 value over there is equal to 35. Next, Q3 value 3 into n plus 1 upon the fourth observation. It is very important for us to write the formula always. So 3 into third observation, if you do, it comes out to be the ninth observation, my friends. So the ninth observation is the sixth, seventh, eighth, and the ninth one, which is 40. So your answer for Q3 is ready and it is equal to 40. Yes, guys, one more example that you have over here is the following data gives units of electricity consumed by a certain family for 9 days in a month. We have to find out the upper quartile and the lower quartile. So when you have to find the upper quartile, you have to find the value of Q3. When you have to find the lower quartile, you have to find the value of Q1. So specifically the question has told you over here that just find the values of the upper and the lower quartile. So here you don't need to find out the value of the second quartile or the Q2 value. So once again, whether you have to find all the three quartiles or any two quartile or in fact any one quartile also, the first thing that we have to do is to arrange the data in the ascending order. So I will say over here that the ascending order is, search for the smallest value over here. I can see it is 18. After 18, the next number that we have is 20, which is coming only for once. After 20, the next value that we have over here is 23, 25, and 29. After 29, the next number that you are having is 30, 32, and 37. After 37, the next number that you have is directly 45. So let us count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I am getting that n is equal to 9 as mentioned in the question. So let us apply the formula for Q1 and Q3 to the ascending order in this example. Q1, 1 into n plus 1 upon the fourth observation, which over here is equal to 9 plus 1, 10 upon the fourth observation, which is the 2.5th observation. So guys, this kind of example I had taken in median also, where if I have a decimal value, we have to split it into two parts. Part which is before the decimal and the part which is after the decimal. So how do we split? We write it like this. Second observation plus 0.5 multiplied by third observation minus the second observation. I'll explain to you once again why we are doing it like this with the help of a small number line. Because on the number line, if you observe, the value 2.5 comes between the second observation and the third observation. Because it comes between second and the third observation, so the additional distance of 0.5 has been covered between the second and the third observation. So this difference of 0.5 or the additional distance of 0.5 is then multiplied with the difference between the second and the third observation, which is written like this: third observation minus the second observation, because we have arranged the data in the ascending order. So 23 is greater than 20. Therefore, I will write over here second observation as 20 plus 0.5 multiplied by 23 minus 20. So it is 0.5. 23 minus 20 is 3. 3 into 0.5 is 1.5. So 20 plus 1.5, that is going to give you equal to 21.5. Question has very clearly mentioned it is units of electricity. So we have to write over here the answer as units. So this is one part of your answer. After that, let us try to get the value of the upper quartile, which is the third quartile. So it is 3 into n plus 1 upon the fourth observation, which is n plus 1 by 4. We have already taken, it is 2.5. So 3 into 2.5th observation, which comes out to be equal to the 7.5th observation. So what is the 7.5th observation? Like we did in the above case, again split it into two parts. Seventh observation is as it is, and you already know that 7.5 comes between the seventh observation and the eighth observation. Therefore, what we will do is we will multiply the additional value or the additional distance of 0.5 with difference between the eighth observation and the seventh observation. So let us search for the seventh and the eighth observation in the ascending order. So it is 1, 2, 3, 4, 5, 6, 7 and 8. So it is between these two numbers 32 and 37. So I write over here 32 plus 0.5 multiplied by 37 minus 32, which is 5. So 32 plus 0.5 multiplied by 5. 5 into 5 is 25, so I can take it as 2.5. 32 plus 2.5, that is going to give us 34.5 units of electricity. So that becomes your required value for Q3. That is your upper quartile. So the next example that you have over here is you are given the marks of the 8 students out of 30 and you have to calculate all the quartiles for this particular case. Once again guys, the first thing that you will do is to find ascending order. So over here it is the smallest value is 5, then 7, then it is 10. Then we are having 12, 15, 16, 19 and 27. So when we want to find all the quartiles, Q1 is 1 into n plus 1 upon the fourth observation, which is equal to Number of observations over here is given to be 8 already, so I can directly take 8 plus 1, 9 upon fourth observation, which is 2.25th observation. So like we did in the above example, it will be splitted again into two parts. Second observation plus 0.25 multiplied by the third observation minus the second observation, but that too you have to be careful to take in the ascending order and not in the actual question. So second observation over here is 7 plus 0.25 multiplied by 10 minus 7. So 7 plus 0.25 multiplied by 3. Now 25 into 3 is 75. So I can take over here 7 plus 0.75. That comes out to be 7.75. So that is the required answer for Q1. Then when we talk about Q2, 2 into n plus 1 upon the fourth observation, which is n plus 1 by 4 we have already taken as 2.25. So directly I can write over here 2 into 2.25th observation, which is now 2.25 multiplied by 2 will give you directly the 4.5th observation. So again I will split it into two parts. Fourth observation plus 0.5 multiplied by. Now this 4.5 lies between the fifth and the fourth observation. Therefore the distance of 0.5 will be taken with fifth observation minus the fourth observation, which is, now let us search for the fourth observation over here. 5, 7, 10 and 12. So that is the fourth observation is 12 and the fifth observation is 15. So I will get over here 12 plus 0.5 multiplied by 15 minus 12. So it is 12 plus 0.5 multiplied by 3. So it is 12 plus 1.5, 13.5. So that is the required value for your Q2. After getting Q2, we also have to find the third quartile, Q3, which is going to be 3 into n plus 1 upon the fourth observation. So this will going to be equal to 3 into 2.25th observation, which is the 6.75th observation. So once again, we will split it into two parts like this. Sixth observation plus 0.75. Now this 6.75 lies between the seventh observation and the sixth observation. Therefore, it will be subtracted and multiplied with 0.75. Seventh observation minus the sixth observation. Yes. So let us search for the sixth observation over here, friends. 1, 2, 3, 4, 5 and 6. So it is 16 and 19. So in this case, 16 plus 0.75 multiplied by 19 minus 16. So 16 plus 0.75 multiplied by 3. So let us multiply this. 5 into 3 is 15, 1 carry. 7 into 3 is 21, 21 and 1, 22. So it is 2.25. So you get the required value for Q3 as 18.25. Is that very simple, guys? Now the next type of data that we are having over here is the ungrouped data, and you are given the calculation to calculate all quartiles for the following data where it is the weight and the number of voices given. So the first thing, friends, you have to again calculate the cumulative frequency values over here. So first value will be the same, it is 2, 2 and 5, that is going to be 7, 14 and 7, 21, 21 and 6 is 27, 27 and 4 is going to give me 31. So that becomes your value for capital N, which is equal to 31. So as per your formula, you have to get over here Q1 n plus 1 upon the fourth observation. So n plus 1 is nothing but 31 plus 1, 32 divided by the fourth observation will be equal to the eighth observation. So friends, you have to just search for a cumulative frequency greater than 8, which over here is 21. So the answer corresponding to 21 is 45. So I can say that this is equal to 45 kilograms is the required value for Q1. All right, so that's the first answer that we have got. After that, when we want to get the value of Q2, twice of capital N plus 1 upon the fourth observation. So this is 2 into the eighth observation, which comes out to be the 16th observation. Now once again over here also, my friends, you are getting the same value. 16 is greater than the cumulative frequency, just greater than 16 is 21. Therefore again the observation corresponding to 21 is 45. So again you will get Q2 is also equal to 45 kilograms. It can happen in certain cases that Q1 and Q2 are equal, or probably Q2 and Q3 are equal. So that does not have any big problem. You can still get complete marks. It all depends on the numbers and the observations that are given to you. So do not worry. You can also get this kind of answer where the two partition values are exactly equal to each other. Now when we talk about Q3, it is 3 into n plus 1 upon the fourth observation, which is 3 into the eighth observation, 24th observation. So if you search for a cumulative frequency just greater than 24, I can see it is 27 and the corresponding value is 55, and therefore my friends, your answer is 55 kilograms is the required value of Q3. Let us start with the next example. It says calculate the upper and the lower quartiles for the following data, and you are given the information of X and F. It can be any characteristic that is under analysis, so we are not worried about what is the characteristic. We just have to find out the upper and the lower quartile, that is the value of Q3 and the value of Q1. So let us see. As you all know, you have to first make the column for the cumulative frequency. So the first frequency value is taken the same. 7 and 15, that will give you 22. 22 and 19 will give me 41. 41 and 23 will give me 64. 64 and 20 is 84. 84 and 15 is 99. 99 and 8, that will give me 107. 107 and 5, that will give me 112. So friends, that becomes your capital N value as 112. Then when I want to find the value of Q1, it is 1 into capital N plus 1 divided by the fourth observation, which is 113 divided by the fourth observation, which is equal to 28.25th observation. As I told you, you don't have to do any kind of splitting up in this. You just have to search for the cumulative frequency value just greater than 28.25, which I can see is 41, and therefore the corresponding answer, which is 25, is the required value for your Q1. Very simple. Similarly, when you want to do for the third quartile Q3, it will be 3 into n plus 1 upon the fourth observation, which is 3 into n plus 1 by 4. We have already seen it is 28.25. So let us just multiply these both numbers. So that will be 5 into 3, that is 15, 1 carry, 3 into 2, 6 and 1, 7, 8 into 3 is 24, and 3 into 2 is 6 and 2, that is 8. So 84.75th observation. So friends, cumulative frequency just greater than 84.75, I can see it is 99, and hence the corresponding value is 40, which is the required value of your Q3. So guys, that is about your quartiles for the raw data and the discrete data. In the next class, we will be studying about the quartiles for the grouped data.